want to keep having a
No, no. Okay. So the question, and Chris is here with me. We're working this through. Each one of, so once you've gotten your functions nailed, and that was the first part is, and I'll just show you what they are. Hopefully you can see the screen okay. The present value, and we found the Wikipedia page last week that just laid them all out there. From there, it's just a matter of punching that into the Microsoft Excel cells or fields. So we know first of all that there's only three numbers. It's the amount, which is either going to be the annuity, present value, or future value. It's going to be one of those three. How long we're running for, and what the interest rate are. So in each case, you just got those three numbers to be input. Now, there are 6 different ways to combine F, P, and A, and here they are. So what I've done is programmed in, and sorry that's not showing up that well, but that if you put in the future value and you want back the present value, it is B6, which in this case is the future value, times this power function. And the power function is just 1 plus B4. That's the percentage. So in this case it's 1.08. And then we're taking it to the negative B5 power. And then I can show you those guys again. Yeah. I think it's all right down here. Yeah. They're right there. So you stick in P. This is the one we just did. You stick in F. That's the function, and then P comes back, and that was that 1 plus the interest rate.
Yeah.
And they get a little gnarlier as you go down, but I can show you how I've got them in here. F over P. Again, it's just that first line we just saw in the Wikipedia page. Let me see if I can get both these on the screen at the same time. Yeah. So I'm translating between the written formulas and what it looks like in Microsoft Excel. So this is B6, which is the well, in this case the present value. There's your power. So and this whole thing right here is power. So 1 plus the interest rate to the term power. Come down here to if you want the annuity as a function of the future value, that's what this one is. Let me just change this to 1 year for the time being. And obviously negative $20,000 now is well the same as a negative $20,000 annuity paid now. So let's just look at that. So that's annuity of the future. So hopefully this is legible. So it's B6. So that's the amount. That's the future value times B4. That's the interest rate. That's sitting right there in the numerator. So those are those two numbers divided by. There's 1 plus the interest rate to the power minus 1. The trick on most of these guys is usually just making sure you got your parens. So this paren and this paren are the arguments for the power function itself. This paren and this paren are just keeping track of my dear Aunt Sally in the denominator, so this minus 1 stays in the denominator and doesn't go sneaking off somewhere. So And from there, it's just, that's really all there is to it. Just keeping track of your parentheses and copying. Now, the question, I think this is what you were asking, Chris, is how do I, once I've got it, how do I use it again?
Yeah, just save it and use it.
Yeah, yeah. So what I did for myself when I first did this problem, I just made one sheet that I called equivalence factors, and it looks exactly like the one we just did. And this isn't, there's more than one ways to do it. So from there, and this is just Microsoft Excel. I click up here. Let me see if I can get my show my keyboard. From here, all I'm doing, got my mouse up here. I click it. I think, yep. And then on my keyboard, I'm hitting. Let me do it once without jumping around too much. Okay, there we go. I click up here, and it's just Control C. Whoops. Control C.
Copy.
Yeah, so I've got my pinky down on the Control, and then, you know, whatever, index finger on the Control C. So now what I can do is, and I've just copied the whole spreadsheet. So now I can come over here on the plus, and I'll just call this problem 1. I'm going to put my cursor up in the corner, and then just do, again, the pinky's down here, Control V. Well, I didn't quite get it, but those are the two keystrokes. Control C, Control V. Another handy one. I'll get my thumb down here in the Alt key and do Alt Tab. So you can see what I'm doing is just kind of toggling through the different things on the screen. I'll use this all day long. It's otherwise you're searching around. So the Alt Tab is handy. In fact, I can just Alt Tab myself back to my camera, maybe not. Anyway, but that's Alt Tab to get through, and just dink 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 whenever you let go. That's the window you land on. And the other ones are just Control C, Control V. You do the same thing in Excel, where if I go back to my equiv factors, and this is what I did on that last one, I just grabbed all the cells. So all I'm doing right now is I've got my mouse, left click up here, drag it, let off the left click button, and again it's just Control C, click down here, Control V. Do that all day long.
Okay.
That's all it is. So I showed you how to copy the whole sheet. Like there's a Control C, get a new one. I'll just call it, PX, problem X. Put the cursor here, Control V. There it is. You can do that, for a whole sheet. You can also do it Control C, Control V, and you can do it within a spreadsheet too. Make sense?
Yep.
Okay, cool. Let's look at problem 6. Problem 6. All right, Joe, thanks for the post. Bauer. What you got here, Bauer? All right. Assume the PV system in problem 3. Actually, let's do problem 3 first. Do problem 3 first. Let me see if I've done that one. P3. Let's read through that one. I don't know if my answer is correct or not. 2. The problems are here, right? In the week 2.
Yep.
Okay. There's a problem. Okay. A 6 kilowatt PV system is estimated to have a salvage value of $7,000 15 years from the date of purchase. In other words, the system could be sold for an extra estimated $7,000, 15 years from installation. Using a discount rate of 9%, how much is the salvage value worth each year? 15 years. Let me think about this. Each year. Okay. The simple way, and I tend to make things more complicated than they are. Let's just see how let's just see how I did this thing. So the, okay, so we know the future value is $7,000. We're told that. We're running for 15 years. The discount is 9%. The easiest way to think, if I'm reading this correctly, the salvage value is the same as $238.41 a year. Just the straight up annuity is a function of the future value. Is that what you got?
Something like that, yeah.
Okay. So I think that's as simple as it, hopefully as it sounds. Problem 6. Assume the PV system in problem number 3 generates 110 kilowatt hours AC each year. Each kilowatt hour of the PV panel rating. So on average produce. All right. So let's knock this thing out. So I'm just going to leave that annuity alone. I'm going to come back to my equivalence factors. I'm going to copy that bad boy. I'm going to copy that there. Go back to problem 6. Looks like I did a little bit of work in there already. Just pop it in. All right, so I'm going to go back where I was. This is going to be the I'm just going to using both the utility payment and the salvage value. So let's just go back to what we know. So here's the salvage. 9%, $7,000. There's our 238. We don't care about those. Okay. So that's the salvage. Now, All right. So the let's just assume here that we're going to make 1,100 kilowatt hours of AC per year. Yeah, 1,100 kilowatt hours of AC per year. What is this stuff? I don't know. Let's just get rid of it. No film. Okay. So let's do power per year. We're going to put this in kilowatt hours. Let's get this over here. Let's put this right here. Let's get these guys scrunched down a little bit. Panel rating. He's not really telling us how big the panel is, but I'm going to assume that we're going to make 1,100 kilowatt hours of AC per year. 1,100, boom, per year. The electric utility is offering a 15-year generation contract to purchase the energy output at a rate of 15 cents per kilowatt hour. Value of energy. This is going to be dollars per kilowatt hour. The answer is 15 cents. 0.15. Dink. Okay, so what we don't really know is that 15 cents now, is it 15 cents per year? I'm just going to assume that it's just 15 cents per every, whatever 15 cents is when you're buying it. So this is going to be basically your income in dollars per year, all right? Because we've got power per year right here, dollars per kilowatt hour, dollars per year, equals that times that. I just have to change this because this is in kilowatts, not dollars. So that's a number. Don't need the decimals. Get rid of those. Okay. So 165 bucks per year of income. Flat rate. Okay. So I'm just going to assume here that all of that energy you make is just going right to the power company. You're not going to use any of it too. What generation payment will be paid at the end of each year based on the actual energy produced that year? Well, here's the deal. It's very unlikely you're going to make exactly the same amount of electricity each year.
Yeah.
So we're not really given that. We're going to just assume that it's the same, and that cost is the same. So we're looking at 165 bucks a year. 15%. What is the present value from the PV system owner's perspective, considering both the utility payment and the salvage value? What are we missing? Well, we're missing what the thing cost in the first place. We don't know what we spent. But from this, we can just say that the amount, I'm going to run this through my little calculator, equals, that's our annuity, and so we want is the present value as a function of the annuity. Sorry. Yeah, and I think what we probably also need, we know that $7,000 is the future value, so we also kind of need the present value. So I'm going to pop that thing. I'm going to copy that. I'm going to paste it right back up here. I can see I got a relative reference. Let me get those back where they need to be. Okay, so if the thing, we know it's going to cost, it's going to be worth $7,000 15 years from now if we're running 9%. That means it's a $1,921.70 system now, because that's the future value. This is the present value. So I'll put that in green. That's the one we care about. We also calculated that we might make $165 a year if it's an 1100 kilowatt system at 15 cents per kilowatt. So that's 165 a year. All I did, I just copied my whole calculation bank, copied that number right in there, and then so that's my present value as a function of my annuity. Oh, except I need 15 years in there, don't I? There we go. So my annuity is 165, and this is the one I'm after, the present value as a function of the annuity. I'm going to paint that guy green. And now I've got the present value of the system, present value of the annuity, equals the sum, present value, $3,176.77. So I don't think I made too many mistakes there. Let's just review it one more time. Again, this is a big assumption. We're going to make 1,100 kilowatt hours per year. We're going to buy it for 15 years at 15 cents per kilowatt hour. We popped all that in right here. So we're going to make $165 a year. And we want to know what's that worth right now. Well, 9%. Whoops. 9%. Okay, that changed it a little bit, but I had 10 in there instead of 9. So 9%, 15 years. This is how much we make each year. So the present value based on the salvage value, and then this is the generation income. The generation income, $165 a year for 15 years at 9%. That has a present value of $1,330, and then the total is right here. Is that? Something still doesn't seem right. Because if it was, no, that can't be right. Present or the future. The present value should be worth more than that. Hey, can you do me a favor?
Mm-hmm.
Just plug this in right here.
Gotcha.
Okay. Let's go back to the original 915.7. 915.7,000.
Looks a little better. Well, you miss one. Parentheses your screen.
Oh yeah, yep. It's pretty unforgiving. Those parens matter. This is looking weird to me all of a sudden. uh, you helped me with this before. 7,000 is my future value,
Mm-hmm.
right? It's 15 years. It's 9%. Why is this? That's
Future value, present value would be, that's right.
But 7,000 is the salvage value, and the thing. Something's wonky. Let me pause. While my brain catches up. Okay, I'm back. I think this is the best I can muster on this one. Yeah, and you know the math is actually pretty simple, but it's the concepts that are difficult. So here's what I'm looking at. Here's what I'm struggling with right now. I'm struggling with the fact that a PV array that's worth $7,000 in the future is only worth $1,922 right now. I mean, it seems to me as if it should be worth more now than it's going to be in the future. I'm just having trouble with the fact that its salvage value is worth more. The way I guess the way I can sort of justify that, and I don't know if it's correct or not, would be to say that I could, if the interest rate is 9%, and the only place I've seen interest rates that high is how much credit card companies charge you. That's what, until you own your own credit card company, your money's not going to be worth that much. But let's just say you are able to, I don't know, instead of investing your money in a PV system, you took and just invested your money in American Express stock, and maybe they're making 11%, and they're willing, if you give them some money now, to pay you at 9%, and they still make their 2%, something to that effect. So, in that sense, you could take your $1,921.70 now and invest it in something that's going to pay back at 9%. Or buy your PV array. Let me think another way through this. Annuity 271. Well, that's the best I can do with it. I'm hoping I get a copy of Fraser's results and solutions here within the next week or two. And there might be something I'm missing here.
I'm trying to do that in my head too. Maybe it's.
Yeah. Well, okay, that's the best I can do on problem 6. So I'm going to leave week 2 alone for now, and let's just spend a little bit of time on week 3 and then call it good.